Welcome to the Bedtime Lab, where we settle down together to explore the wonders of the universe with a gentle curiosity. Tonight, I invite you to join me on a dreamy journey through the celestial beauty of Saturn's rings and moons. As you get comfortable, feel free to share where you're joining us from in the comments below. It's always a delight to know where our fellow stargazers are nestled around the world. Let me share something interesting about Saturn. Did you know that its rings are much younger than the planet itself? While Saturn has been around for over 4 billion years, its rings are believed to be only a few 100 million years old. It's almost like having a timeless parent with a brand new wardrobe. This makes us wonder about the cosmic events that led to the formation of these striking features. Speaking of the rings, they aren't solid structures as they might appear from afar. Instead, they are made of countless particles of ice and rock, each one reflecting sunlight like tiny mirrors. Some of these particles are no larger than grains of sand, while others are as big as small houses. Can you imagine the diversity among these countless little worlds? Here's a fascinating fact. If Saturn's rings were spread out flat, they would span across nearly 300,000 kilometers, yet their thickness is astonishingly thin. In some areas, they're only about 10 meters thick, which is thinner than a pancake if you were to scale it down to a human-sized plate. This delicate balance of vastness and fragility is truly remarkable, wouldn't you agree? Now, let me take you beyond the rings to explore Saturn's moons. Did you know that Saturn has over 80 moons? Each one is a world of its own, with unique stories and mysteries. For instance, Titan, the largest of them all, is even bigger than the planet Mercury. Titan has a dense atmosphere and lakes of liquid methane, creating a landscape that is both alien and captivating. Speaking of which, have you ever heard of Enceladus? This icy moon might look unassuming at first glance, but it hides a secret beneath its frozen surface, a vast ocean of liquid water. Scientists believe that hydrothermal activity occurs at the ocean's floor, making Enceladus one of the prime candidates in the search for extraterrestrial life. Isn't it fascinating to think that such possibilities exist just beyond our reach? Here's something intriguing. Saturn's moon, Iapetus, has a striking two-tone appearance. One side is as dark as coal, while the other is bright and icy. This stark contrast has puzzled scientists for decades, sparking countless theories about its causes. Some suggest that Iapetus has been coated with material from another moon, while others propose that it might be due to ancient surface activities. The mysteries of the night sky never cease to amaze us, do they? And here's another alluring fact. Janus and Epimetheus, two of Saturn's smaller moons, share an extraordinary relationship. They're known as co-orbital moons, meaning they dance around Saturn on nearly the same path. Every 4 years, they swap places in a celestial ballet that is both graceful and complex. It's as though these moons are partners in an endless waltz across the heavens. Transitioning back to the rings for a moment, have you ever wondered why they appear so vibrant and colorful in some images? This vivid display is due to the interaction of sunlight with the icy particles, scattering light in various ways to produce those beautiful hues. The colors are often more subtle and muted to the human eye, but with the help of telescopes and spacecraft, we're able to witness the spectacle in all its glory. Now, let's consider Mimas, a moon that has captured the imaginations of many due to its resemblance to a famous fictional space station. Its surface is dominated by a massive crater named Herschel, which gives it an uncanny likeness to the Death Star from Star Wars. Despite its striking appearance, Mimas is a world of its own, quietly orbiting Saturn and holding its secrets close. Here's a delightful nugget of information. The rings of Saturn are named alphabetically in the order they were discovered. However, this does not correspond to their order from the planet. The innermost ring is actually the D ring, followed by the C, B, A, F, G, and E rings. It's a little cosmic puzzle that invites us to think about the history of our celestial discoveries. And did you know that the gravitational pull of Saturn's moons influences the rings in intriguing ways? Moons like Pan and Daphnis carve out gaps and waves within the rings, creating dynamic patterns that change over time. It's almost as if the moons are artists, using the rings as their ever-shifting canvas. As we continue to explore, remember that the night sky is full of wonders, waiting to be discovered. Each moon, each ring, carries with it a story of creation and change, of ancient collisions and quiet revolutions. These celestial bodies remind us of the vastness of the universe and the beauty that lies in its mysteries. As we drift through this galaxy of information, let the wonders of Saturn's rings and moons fill your thoughts like a gentle lullaby. The universe is a vast tapestry, and tonight we've woven a little more of its intricate design into our dreams. Sweet dreams, dear friends, and until next time, may the stars guide you gently to sleep. Saturn's rings might give the impression of being timeless, but did you know they might actually be quite young in cosmic terms? Some scientists believe the rings could be just 100 million years old, formed from the remnants of a shattered moon or comet that wandered too close to Saturn. Imagine the dramatic event that must have been, leaving behind this breathtaking display. Switching our focus back to Titan for a moment, have you ever considered how it rains on this moon? Unlike Earth's water-based rain, Titan experiences showers of liquid methane. The raindrops fall slowly due to the thick atmosphere, making it a gentle drizzle that shapes the moon's landscapes over time. Can you picture standing in a methane rainstorm beneath its hazy skies? Here's something curious. Among Saturn's moons, one is named after a giant from Greek mythology. Hyperion is known for its chaotic rotation, a rare phenomenon in the solar system. Its tumbling path means that if you stood on its surface, you would see the sun rise and set unpredictably in different places each day. It's as if Hyperion itself is caught in a cosmic dance, turning every which way. Have you heard of the shepherd moons? These small moons, like Pandora and Prometheus, help maintain the structure of certain rings. They act like cosmic shepherds, using their gravity to keep the ring particles within boundaries. Without these guardian moons, the rings would lose their sharp edges and eventually disperse into space. Isn't it intriguing that Rhea, another of Saturn's moons, might have its own thin atmosphere? Although it's not dense enough to breathe, this exosphere contains oxygen and carbon dioxide, hinting at chemical processes beneath its icy surface. It opens up a tantalizing possibility for future explorers as we continue to uncover the secrets hidden within these distant worlds. Let's ponder the case of Saturn's moon Tethys. It's home to an enormous chasm called Ithaca Chasma, which stretches nearly 2,000 kilometers across the moon's surface. This canyon-like feature is believed to have been formed by internal forces, or perhaps by a massive impact. Just imagine a geological wonder that spans such a vast distance in the cold depths of space. Speaking of impacts, Saturn's rings are constantly bombarded by micrometeoroids. These tiny space rocks strike the particles in the rings, causing them to emit a faint glow as they collide. This process, called sputtering, can change the ring's brightness and even alter their composition over time, a reminder of the ever-evolving nature of our universe. Now, let me tell you about something truly remarkable. The moon Enceladus not only harbors an ocean beneath its icy crust, but also shoots geysers of water vapor into space. These plumes, discovered by the Cassini spacecraft, are like fountains from another world. They're filled with organic molecules, possibly hinting at the presence of life beneath the icy surface. Isn't that a captivating thought? Consider also the tiny moon Pan, which orbits within the Encke gap of Saturn's A ring. This moon looks like a cosmic flying saucer due to its equatorial ridge, a feature that resulted from accumulated ring material. Its unique shape and location make Pan a fascinating object of study, nestled within the vast ring system like a pearl in an oyster. In another corner of Saturn's domain, we find the curious moon of Dione. Scientists have discovered longitudinal stripes on its surface, known as tiger stripes. These features are similar to those on Enceladus, suggesting possible tectonic activity. It makes one wonder what forces lie beneath the cold exteriors of these distant worlds, shaping them in ways we are only beginning to understand. And here's a delightful tidbit. Saturn's rings can actually create their own meteor showers on the planet. As meteoroids smash into the rings, they create debris that eventually descends into Saturn's atmosphere. These tiny particles, pulled along by gravity, create what can be described as an ethereal rain. The idea of meteors raining down from rings is both beautiful and unexpected. Let's not forget about Phoebe, a moon that orbits Saturn in the opposite direction to most of its siblings. This retrograde orbit hints that Phoebe may be a captured object, perhaps a remnant of the primordial solar system. It serves as a living museum piece, offering insights into the materials and conditions present in the early solar system. And finally, consider this. The gravitational interactions between Saturn's moons and rings can create waves similar to those in our oceans. These spiral density waves ripple through the rings, traveling across vast distances and producing a symphony of motion. It's a reminder of the delicate balance and harmony that exists even in the cold, distant reaches of space. As we reflect on these celestial wonders, we find ourselves wrapped in the stories and mysteries of Saturn's rings and moons. Each fact adds a new layer to our understanding, painting a picture of a dynamic and lively system far beyond our blue planet. In the quiet of the night, let these tales of cosmic exploration lull you into a peaceful slumber, dreaming of worlds yet to be explored. Did you know that Saturn's rings are primarily made of water ice? These icy particles range in size from tiny grains to massive chunks, some as large as small houses. The ring's brilliant shine is due to the reflective nature of the ice, casting ethereal glow that has fascinated astronomers for centuries. Imagine the soft, shimmering light that must envelop the planet as sunlight glints off these icy particles, creating a breathtaking celestial display. Curiously, Saturn's rings are not as ancient as one might think. Researchers believe they may have formed between 10 and 100 million years ago, relatively young in cosmic terms. It's as if the rings are a new addition to the solar family, still fresh and vibrant. The youthfulness of the rings invites us to ponder their origins and the cosmic events that brought them into being. Here's something intriguing. Saturn's moon Iapetus has a startling two-tone appearance. One hemisphere is as dark as coal, while the other is bright like fresh snow. This stark contrast is thought to result from a layer of dark material coating one side, perhaps from a collision or the accumulation of material from outside the moon. The visual contrast paints a striking picture, like a yin-yang symbol drifting through the cosmos. Speaking of cosmic artistry, the rings of Saturn aren't perfectly uniform. They contain gaps and divisions, such as the Cassini division, a wide space between the A and B rings. These divisions are not empty, but contain thinner rings and diffuse material. The intricate structure within these gaps tells a story of gravitational interactions and the delicate dance of particles, showcasing the complexity and beauty inherent in Saturn's ring system. Let's turn our gaze to one of Saturn's most intriguing moons, Mimas. At first glance, it might remind you of the Death Star from Star Wars due to its massive crater, Herschel, which is nearly 1/3 the diameter of the Moon itself. This staggering impact feature gives Mimas a unique appearance and hints at a significant collision in its past. It's a vivid reminder of the dynamic and sometimes violent history of our solar system. And here's a quaint fact. Saturn has a moon named after a character from Shakespeare, Juliet. Orbiting within Saturn's outermost ring, this moon is part of a group collectively known as the Shakespearean moons. Their names, drawn from the works of the bard, add a poetic touch to the vast and varied Saturnian system, reminding us of the timeless interplay between science and art. Moving on, we have the moon Rhea, which hosts a peculiar feature known as wispy terrain. These bright, streaky markings crisscross the surface, thought to be composed of water ice and possibly the remnants of ancient tectonic activity. It's like nature's way of etching its history onto the moon's face, leaving behind a map to be deciphered by curious minds. Have you ever wondered about the sound of Saturn's rings? Though space is a silent vacuum, the particles within the rings can vibrate and create waves. When translated into sound, these vibrations produce eerie, musical tones, providing an auditory glimpse into the unseen processes within the ring system. It's a silent symphony, hidden from earthen ears but no less enchanting. Saturn's moon Enceladus, known for its icy geysers, is also one of the most reflective bodies in the solar system. Its surface is composed almost entirely of fresh ice, creating a mirror-like sheen that reflects nearly all the sunlight that hits it. This high albedo makes Enceladus stand out against the backdrop of space, a shining beacon hinting at the mysteries beneath its surface. There's a curious phenomenon occurring in Saturn's rings called spokes. These are transient features that appear as dark radial markings, moving rapidly across the rings. Scientists believe they may be caused by interactions with Saturn's magnetic field, lifting small particles above the plane of the rings. The fleeting nature of these spokes adds an element of mystery to the already complex dynamics of Saturn's rings. And while we're on the topic of fleeting phenomena, consider the ring arcs of Saturn's moon arcs. These partial rings are made up of clustered particles and are thought to be stabilized by the gravitational influence of nearby moons. The presence of these arcs suggests a delicate gravitational balance, a cosmic tug-of-war that keeps them from dispersing into space. Saturn's rings might be primarily icy, but did you know they contain a significant amount of rocky material as well? This rock content varies across different rings, influenced by the size and composition of the particles. The mix of ice and rock creates a complex system where each ring tells a different story about its origin and evolution, a testament to the diversity of materials in our solar neighborhood. Finally, let's explore the temperature extremes within Saturn's rings. Despite their icy composition, the rings can reach temperatures of -200 degrees Celsius. However, parts exposed directly to sunlight can warm up to more temperate conditions, This stark contrast in temperature across the rings mirrors the broader extremes found throughout the Saturnian system, an intricate balance of light and shadow sculpted by the distant sun. In the stillness of the night, let these tales of Saturn's rings and moons dance in your mind, inviting dreams of distant worlds and celestial wonders. Each fact weaves a thread in the grand tapestry of the cosmos, a gentle reminder of the endless mysteries waiting to be discovered beyond our earthly horizons. Did you know that Saturn's rings are not a solid structure, but rather a collection of countless tiny particles, ranging in size from minuscule grains of dust to massive chunks as large as mountains? This dynamic collection moves in unison around the planet, like a celestial ballet where each particle plays its part in the grand choreography of cosmic motion. These particles are primarily composed of water ice, giving the rings their brilliant shining appearance when viewed from afar. One fascinating aspect of Saturn's rings is their incredible thinness relative to their vast width. Imagine a sheet of paper stretched across a football field. Saturn's rings are similarly thin when scaled to their immense span, which stretches over 270,000 kilometers. This startling thinness adds to their delicate nature, making them a wonder of structural balance in the solar system. Now, let me tell you about an intriguing feature known as shepherd moons. These are small moons that orbit within or near the edges of Saturn's rings, and their gravitational forces help keep the ring particles in place. Imagine a shepherd guiding its flock. These moons maintain the order and shape of the rings, preventing them from dispersing into space. One famous pair of shepherd moons are Prometheus and Pandora, which help maintain the sharp edges of the F-ring with their gravitational pull. Speaking of moons, Saturn's moon Titan is shrouded in mystery and thick layers of golden haze. Titan is the second largest moon in the solar system and is unique with its dense atmosphere and surface lakes of liquid methane and ethane. Its atmosphere is so thick that the surface is hidden from view, prompting scientists to use radar to peer through the haze and reveal the landscape beneath. The presence of these hydrocarbon lakes makes Titan a fascinating subject for the study of prebiotic chemistry and the search for life beyond Earth. Now, there's something truly unusual about another of Saturn's moons, Hyperion. This moon has a chaotic rotation, meaning it doesn't spin uniformly like most celestial bodies. Instead, its axis of rotation wobbles unpredictably due to its irregular shape and the gravitational influence of nearby moons. This chaotic dance results in a constantly changing view of Hyperion as it tumbles through space, a reminder of the unpredictable nature of celestial mechanics. Here's a delightful tidbit. The rings of Saturn sometimes appear to disappear from view. This is not magic, but a result of Saturn's axial tilt. As Saturn orbits the Sun, the rings occasionally align edge-on with Earth, becoming nearly invisible due to their thinness. This phenomenon, known as a ring plane crossing, allows us a rare glimpse of the rings from a unique perspective, highlighting their fragile beauty. Saturn's moon Enceladus, with its icy geysers, holds a treasure beneath its surface, a global ocean of liquid water. The presence of this subsurface ocean, heated by tidal forces from Saturn, raises intriguing possibilities for life. As these geysers erupt, they spew water vapor and ice particles into space, contributing to one of Saturn's outer rings and offering tantalizing hints of the moon's hidden secrets. Interestingly, the rings of Saturn have their own weather patterns. Scientists have observed that the rings can experience ring rain, where charged water molecules from the rings are pulled into Saturn's atmosphere by its magnetic field. This process not only affects the composition of the rings, but also contributes to the planet's auroras, creating a fascinating interplay between the rings and the planet they orbit. Moving on, Saturn's moon Tethys holds a feature known as Ithaca Chasma, a massive canyon that stretches nearly 3/4 of the way around the moon. This colossal chasm is thought to be the result of the moon's interior cooling and contracting, causing the surface to crack and split. It's a geological scar from the moon's ancient past, whispering stories of the forces that have shaped it over billions of years. On the topic of storytelling landscapes, Saturn's moon Iapetus also offers a curious ridge running along its equator. This ridge is so tall, it gives the moon an appearance not unlike a walnut. The formation's origin remains a mystery, with theories suggesting it may be the remnants of ancient geological activity or material accumulated from a past ring system. Either way, it adds a puzzling feature to this already enigmatic moon. Did you know that some of Saturn's moons are part-time contributors to the rings? For example, the surface material ejected from Enceladus's geysers feeds into the E-ring, while material from meteorite impacts on other moons replenishes the rings as well. This dynamic exchange of material showcases the interconnected nature of Saturn's moons and rings, continuously shaping and reshaping the Saturnian system. Interestingly, Saturn's rings are relatively young, perhaps only a few 100 million years old. This means they did not form alongside the planet, suggesting they could be the remnants of a moon or comet that was torn apart by Saturn's immense gravity. The youth of the rings continues to be a subject of scientific debate as researchers seek to uncover the events that led to their formation. Finally, let's consider the gravitational influence Saturn itself exerts on its ring particles. As these particles orbit the planet, they create waves that ripple through the rings, akin to the wake of a boat on water. These waves can be detected and studied, revealing information about the internal structure of Saturn, such as its core and its rotation. This interaction between the planet and its rings is a beautiful example of how the cosmos is an interconnected web of forces and motions. As these celestial stories unfold, they weave a rich tapestry of wonder and discovery, inviting us to dream deeper and soar higher among the stars. Let me share with you a rather surprising detail about Saturn's moon Dione. It might look like just another icy moon, but Dione has a hidden secret. Spectral analysis hints at the presence of oxygen ions in its thin atmosphere. This discovery suggests that despite its icy surface, there might be more chemical activity than meets the eye. It's fascinating to think about these little bubbles of oxygen quietly existing in the icy silence of space, isn't it? And speaking of hidden wonders, have you heard about Saturn's ring spokes? These mysterious, ghostly features appear as dark radial lines that stretch across the rings. They are believed to be caused by electrostatic charges lifting small particles above the ring plane. The spokes appear and disappear with the changing seasons on Saturn, offering a reminder of how this majestic planet constantly surprises us with its dynamic nature. Here's another intriguing snippet. The moon Mimas, often likened to the Death Star from Star Wars due to its large impact crater, is more than just an icy body with a striking resemblance to science fiction. Mimas exhibits a curious wobble in its orbit, suggesting the possibility of an internal ocean beneath its frozen surface. This hidden sea, tucked away under kilometers of ice, challenges our understanding of what these seemingly barren worlds could conceal. Meanwhile, the moon Rhea might leave you pondering about rings in unexpected places. Rhea is the only moon in the solar system that might have its own rings, albeit faint and composed of debris possibly left from a past collision. Imagine a moon with its own miniature ring system, silently circling in the vastness of space. Did you know that Saturn's rings are not as solitary as they might appear? Tiny moonlets, some only a few hundred meters across, reside within the rings, causing spiral density waves. These waves propagate through the rings, akin to ripples in a pond, sculpting intricate patterns that change with time. These moonlets, acting as unseen architects, shape the very structure of the rings they inhabit. And there's more to Saturn's rings than meets the eye. The rings are mostly made of water ice, but there are also traces of rocky material and organic compounds. This blend of ice and rock not only gives the rings their shimmering appearance, but also suggests a complex history of formation and evolution. The story of the rings continues to be written with every observation and study. Let's explore the peculiarities of Saturn's moon Iapetus once more. Its surface is a study in contrasts, with one hemisphere as dark as asphalt and the other bright as snow. This stark dichotomy might be due to material from another moon, Phoebe, coating one side, while the other remains untouched. It's like Iapetus wears a cosmic mask, half hidden in shadow, half illuminated. Shall we delve into the enigmatic Titan once more? Titan, with its dense atmosphere, experiences weather patterns unlike any other moon. Methane clouds form and dissipate, creating rain that fills lakes and rivers. This alien hydrological cycle, driven by methane instead of water, paints a vivid picture of a world both familiar and foreign, echoing Earth's own water cycles. There's something mesmerizing about the moon Enceladus. Its iconic icy plumes, which erupt from surface fractures known as tiger stripes, are not just beautiful spectacles. These plumes contain salty water and organic molecules, hinting at hydrothermal activity beneath the surface. This suggests Enceladus might harbor conditions suitable for life, a thought that beckons scientists to explore further. Have you ever imagined a world where the sky is dominated by rings? If you stood on Saturn's moon Tethys, you'd see Saturn's rings arching across the sky, a celestial spectacle like no other. Such views remind us of the diverse vantage points throughout our solar system, each offering a unique panorama of cosmic beauty. Now, consider the moon pan, nestled within the Anchor Gap in Saturn's A-ring. This tiny moon shapes the gap with its gravity, creating a distinct boundary. Pan's ridge-like structure makes it look like a little cosmic ravioli, showcasing the whimsical diversity of shapes moons can take. In addition, the rings of Saturn aren't uniform in thickness. Some sections are dense and crowded with material, while others are sparse, like a thin veil. The varying thicknesses provide clues to the rings' origins and age, as well as the forces that have sculpted them over time. Exploring further, Saturn's moon Tethys presents another marvel, the phenomenon of synchronous rotation. This means Tethys always shows the same face to Saturn, much like our moon with Earth. This dance of gravitational forces ensures that one hemisphere bathes in Saturn's light, while the other peers into the darkness of space. And here's a delightful curiosity about Saturn's B-ring. This section of the rings contains spokes that defy gravity briefly, hinting at complex electromagnetic interactions. These spokes form and vanish, a testament to the intricate ballet of forces at play within the rings. Lastly, let's not forget the role of Saturn's immense magnetic field. Extending far beyond the planet, it interacts with the icy particles of the rings, charging them and influencing their movements. This magnetic orchestra shapes the rhythm and flow of the rings, painting a picture of cosmic serenity that is anything but static. As we drift through these celestial wonders, each fact becomes a brushstroke in the grand mural of the Saturnian system, inviting us to listen closely to the whispers of the cosmos. Let me take you on a journey to Saturn's remarkable moon, Hyperion, which spins chaotically as it orbits the planet. Unlike most moons which rotate in a predictable manner, Hyperion's rotation is erratic and unpredictable. Imagine a world tumbling through space, never repeating the same orientation twice. This unusual spin is due to its irregular shape and the gravitational influences of Saturn and other nearby moons, making Hyperion a captivating celestial oddity. Speaking of oddities, have you ever wondered about the temperature of Saturn's rings? Despite their icy composition, the rings experience significant temperature variations. During Saturn's long winter nights, the rings can become incredibly cold, dropping to temperatures as low as -200 degrees Celsius. But as the sun rises, the temperature can soar, creating an extraordinary range that adds another layer to the ring's ever-changing nature. Here's something intriguing. Saturn's moon Atlas, which orbits near the edge of the A-ring, has a striking shape that resembles a flying saucer. This peculiar form is due to the accumulation of ring material along its equator, creating a pronounced ridge. Picture a tiny moon with a broad, flat equatorial ridge, spinning gracefully within the rings like a cosmic disk. And then there's the mystery of the missing ring. Saturn may have once had a massive ring that has since disappeared. Scientists believe that a giant ring, perhaps made of rocky debris, could have existed in the distant past. Over time, this ring might have coalesced to form some of Saturn's current moons, a captivating tale of destruction and creation unfolding over millions of years. Consider the moon Dione, with its bright icy surface crisscrossed by wispy streaks. These streaks are actually ice cliffs, remnants of tectonic activity beneath Dione's surface. Imagine towering ice cliffs, remnants of ancient forces that have shaped the moon into its current form. This icy landscape invites us to ponder the geological processes that occur on these remote worlds. Did you know that Saturn's rings are not uniform in color? These icy bands exhibit subtle shades of pink, brown, and gray, a result of varying particle composition and size. The interplay of light on these colorful particles creates a shimmering spectrum, a visual symphony playing across the vast expanse of the rings. Gaze upon the moon Rhea once more, and you'll find a surface scattered with craters that speak of ancient impacts. Among these craters lies a large, mysterious scar known as the Great Scar. This gash, which spans the equatorial region, hints at a colossal event in Rhea's past, possibly caused by a massive collision that left an indelible mark on its surface. Now, let's consider the gravitational influence of Saturn's moons on the rings. As the moons move through their orbits, they create gravitational resonances that can clear gaps in the rings or create beautiful features like the Cassini division. This vast gap, sitting between the A and B rings, is the result of the gravitational dance between the moons and the rings, a celestial ballet that shapes the Saturnian system. Here's a fascinating thought. The small moons within Saturn's rings, known as shepherd moons, play a crucial role in maintaining the ring's sharp edges. These moons, such as Prometheus and Pandora, guide the ring particles with their gravity, keeping the particles in line and preserving the ring's crisp boundaries. It's as if these tiny moons are cosmic caretakers. Let's embark on a mental journey to Saturn's moon Janus. This moon shares its orbit with another moon, Epimetheus, in a unique arrangement known as co-orbital motion. Every few years, these moons swap places, a cosmic dance that occurs due to their gravitational interactions. Imagine two celestial partners waltzing elegantly, exchanging positions as they orbit their giant host. And here's something curious. The gaps within Saturn's rings, like the Encke and Keeler gaps, are not empty spaces. Within these gaps, you'll find tiny moonlets that carve out their paths and contribute to the dynamic nature of the rings. These hidden travelers, though small, influence the structure and movement of the rings, adding to the complexity of the Saturnian environment. Reflecting on the beauty and mystery of Saturn's rings and moons, you might wonder about their origins. While the precise history remains elusive, some scientists suggest the rings could be remnants of a destroyed moon, torn apart by Saturn's gravity long ago. This theory paints a dramatic image of cosmic forces at work, crafting the stunning rings we see today from the remnants of a once proud celestial body. Envisage the moon Phoebe, with its retrograde orbit, moving in the opposite direction to most of Saturn's moons. This backward path suggests that Phoebe may be a captured object, perhaps an icy body from the distant Kuiper belt. Such a scenario hints at the complex migrations and interactions that sculpt the solar system's architecture over eons. Finally, ponder the influence of solar eclipses on Saturn. These celestial events, caused by its moons passing in front of the Sun, cast shadows onto the rings, creating intricate patterns of light and shadow. These fleeting moments, recorded by passing spacecraft, reveal the delicate interplay between light and darkness on one of the most enchanting planets in our solar system. As you drift away with these thoughts, let the wonders of Saturn and its dazzling companions guide you into a peaceful slumber. When you think about Saturn's moon Titan, it's fascinating to know that it's the only moon in our solar system with a dense atmosphere. This atmosphere is rich in nitrogen, much like Earth's, but it also contains methane and ethane, creating a hazy orange veil that shrouds the surface. Imagine peering through this thick atmosphere to discover vast lakes and rivers of liquid methane and ethane, a world where the rain falls not as water, but as hydrocarbons. Did you know that Tethys, another of Saturn's moons, has a giant canyon named Ithaca Chasma? This chasm stretches nearly 2,000 kilometers long, which is about 3/4 of the moon's circumference. Picture a canyon so vast that it wraps around a significant portion of this icy moon, a reminder of the ancient forces that tore through Tethys' surface. Now consider Hyperion, a moon with a chaotic rotation. Unlike most moons that spin in a regular, predictable manner, Hyperion tumbles unpredictably through space. Its irregular shape and gravitational interactions with other moons give it a bizarre, erratic spin, making each day on Hyperion wildly different from the last. Can you imagine living on a moon where the sun's position in the sky is never the same twice? Speaking of unusual shapes, Saturn's moon pan is often compared to a flying saucer. It's not just an abstract description. Pan has a distinctive equatorial ridge, giving it the appearance of a ravioli or some other delightful pastry. This peculiar shape results from ring material accumulating around its equator, a striking example of how celestial bodies can assume the most unexpected forms. Here's something you might find intriguing. Saturn's rings are relatively young on a cosmic scale. Scientists estimate that they are less than 100 million years old, much younger than Saturn itself. One theory is that the rings could be the remnants of a comet or a former moon that was torn apart by Saturn's gravity. This notion of recent creation adds a layer of mystery to an already enigmatic feature. Have you ever wondered about the smallest moonlets within Saturn's rings? Some of these diminutive bodies, such as Daphnis, are mere kilometers across. Despite their tiny stature, these moonlets have a profound impact, carving out narrow gaps and creating waves in the surrounding ring particles. Visualize these tiny sculptures, each playing its part in the ongoing evolution of Saturn's rings. Enceladus is a moon that offers surprises beneath its icy exterior. Did you know it's one of the most promising places in the solar system to search for extraterrestrial life? Beneath its frozen crust, there lies a global ocean of liquid water, kept warm by geothermal activity. The geysers that erupt from Enceladus's south pole send water vapor, ice particles, and organic compounds into space, a tantalizing hint of the conditions that might support life. And here's a captivating detail. The rings of Saturn are exceedingly thin, especially when you consider their massive diameter. In some places, they are no thicker than a single football field, despite stretching over 270,000 kilometers in diameter. This thinness makes the rings delicate and allows them to cast intricate shadows on the planet's cloud tops, a dance of light and form that mesmerizes observers. Let's journey back to Titan, where the dunes offer another marvel. These are not like the sandy dunes of Earth, but are composed of dark hydrocarbon grains. Stretching for hundreds of kilometers, these dunes are shaped by the winds on Titan, giving us a glimpse into the weather and climate of this distant world. Now, imagine the moon Iapetus, with its two-tone coloration. One hemisphere is as dark as coal, while the other is bright and icy, a striking contrast that has puzzled scientists for centuries. This moon's unique appearance is thought to result from the accumulation of dark material on one side, possibly swept up as Iapetus travels through space. Did you know that Saturn's gravitational pull can actually affect the shape of its moons? Mimas, for instance, despite appearing round, actually has a slightly elongated form because of the tidal forces imposed by Saturn. This influence shapes not just the physical form of moons, but also their internal structures and geological activity. Speaking of Mimas, it bears an uncanny resemblance to the Death Star from the Star Wars saga. This likeness is due to its large crater Herschel, which dominates one hemisphere. The crater's central peak and massive walls give Mimas a distinctly familiar silhouette, connecting our cosmic observations with popular culture. Finally, let's contemplate the enigmatic F ring. Unlike the other rings, this ring is narrow and twisted, with kinks and braids caused by interactions with nearby shepherd moons. These moons tug and pull on the ring particles, creating a mesmerizing, ever-changing spectacle that showcases the dynamic nature of Saturn's rings. As these facts swirl in your mind like the particles in Saturn's rings, let your imagination wander through the cosmic theater of Saturn's celestial dance. Each moon, ring, and shadow tells its own story, a chapter in the grand narrative of our solar system that invites endless wonder. Let me share something intriguing about Saturn's lesser-known moon, Dione. It may look unassuming at first, but beneath its icy surface there might be a liquid ocean. Did you know that gravitational interactions with Saturn and other moons generate enough heat to potentially maintain a subsurface ocean? It's a reminder that even the most seemingly tranquil places hold hidden depths. Speaking of surprises beneath the surface, have you ever heard of cryovolcanoes? On Enceladus, these ice volcanoes erupt with water vapor and ice instead of molten rock. It's like a wintry wonderland where geysers shoot into the sky, adding material to Saturn's E-ring and hinting at the dynamic processes occurring below the icy crust. Imagine a moon where the surface is so bright it reflects nearly all the sunlight that reaches it. That's Rhea, Saturn's second largest moon, with a surface made mostly of water ice. Its albedo, or reflectivity, is so high that it's like a cosmic mirror. Can you picture a place so reflective that it shines brilliantly against the dark backdrop of space? Now, let's ponder the intriguing phenomenon of ring spokes. These are transient, radial features that appear in Saturn's rings, resembling the spokes of a wheel. Scientists believe they are caused by electrically charged particles being lifted above the ring plane by Saturn's magnetic field. It's another example of the fascinating interplay between the planet's rings and its magnetic environment. And here's something curious. Did you know that Saturn's gravity is so strong it causes its rings to occasionally warp and ripple? As the planet's gravitational pull interacts with the rings, it creates waves that travel through the ring particles, like ripples on a pond. These waves can provide insights into the mass and composition of the rings themselves. Let me tell you about the moon Epimetheus, which shares its orbit with another moon named Janus. Unlike most satellites that have a clear path around their planet, these two moons engage in a celestial dance. Every few years, they swap orbits in a cosmic ballet choreographed by their gravitational interactions. Can you imagine such elegance in the heavens? Have you heard about Titan's mysterious magic islands? Occasionally, structures appear and disappear on the surface of its hydrocarbon seas, as if by magic. These are likely caused by floating debris, rising gas bubbles, or even waves stirred by the wind. It's a reminder of the ever-changing nature of this distant moon's lakes and seas. Speaking of Titan, its thick atmosphere creates a greenhouse effect, warming the surface to about -179 degrees Celsius, which is significantly warmer than it would be without this atmospheric blanket. This warmth allows for the complex hydrocarbon chemistry we observe, providing tantalizing hints of processes that might one day be similar to early Earth. Here's a fascinating fact about Saturn's rings. They contain countless gaps and divisions, some of which are named after earthly composers. The most famous of these is the Cassini division, a wide, dark gap between the A and B rings. These gaps are often maintained by the gravitational influence of nearby moons, creating a symphony of space and matter named in honor of human creativity. Imagine a moon with an atmosphere so thin it's almost negligible. That's the case with my Mars, whose surface is marked by stark temperature differences between sunlight and shadow. Its lack of a substantial atmosphere means there's little to moderate these extremes, resulting in a surface that can abruptly change from freezing to slightly less freezing. Let me share something about Saturn's inner D ring. It's the closest ring to the planet and is much fainter than the others. Its particles are constantly interacting with Saturn's atmosphere, slowly spiraling inwards. This interaction causes them to gradually disappear, a slow dance of decay that's part of the ever-changing tapestry of Saturn's rings. Have you ever wondered about the moon Atlas? This small moon has an unusual shape, with a prominent equatorial ridge, similar to that of Pan. This ridge makes Atlas resemble a flying saucer, a shape likely caused by accumulations of ring particles. It's another reminder of the creative and diverse forms found among Saturn's many moons. Speaking of interesting forms, consider the shepherd moons Prometheus and Pandora. They orbit near Saturn's F ring, their gravitational influences maintaining the ring's narrow shape despite its chaotic appearance. These moons act as cosmic guardians, their presence ensuring the ring remains a distinct and mesmerizing feature. Now, let's explore the idea of ring rain. Did you know that charged particles from Saturn's rings slowly drift down onto the planet, creating a kind of ethereal rain? This process not only affects the rings, but also contributes to Saturn's atmospheric composition, a gentle reminder of the interconnectedness of the planet and its beautiful rings. Finally, think about the resonance between the rings and Saturn's moons. These resonances create gaps and maintain stability within the ring system, a cosmic dance choreographed by gravity and orbital dynamics. These interactions are a testament to the complexity and beauty of celestial mechanics, where every element has its part to play in the grand performance surrounding Saturn. Did you ever wonder why Saturn's rings can appear so bright, even from millions of kilometers away? Let me share with you something fascinating. The rings are composed mostly of water ice, reflecting sunlight much like freshly fallen snow. This high reflectivity is part of what makes Saturn's rings such a striking sight. However, here's an intriguing twist. The particles in the rings also vary in size, from as small as tiny grains to as large as boulders several meters across. Each particle, big or small, contributes to the shimmering beauty you see from afar. Speaking of variety, there's something curious about Saturn's moon, Hyperion. Unlike most moons which tend to be spherical, Hyperion has an irregular, almost sponge-like shape. Its surface is heavily cratered, with one large crater dominating its appearance. Scientists think Hyperion's odd shape and sponge-like appearance are due to its low density and porous nature. This low density means it may be mostly empty space inside, a testament to the surprising diversity of form and structure in Saturn's family of moons. Now, let's talk about something captivating happening on Titan, Saturn's largest moon. Titan has vast lakes and seas filled not with water, but with liquid methane and ethane. Imagine standing on its surface, where rain falls not as water, but as hydrocarbons. These lakes even have shorelines that change over time, much like the lakes and seas on Earth. The existence of these methane lakes is a reminder of the alien yet familiar processes occurring in the outer reaches of our solar system. And here's something unusual about Saturn's moon, Iapetus. It has a striking two-tone coloration, with one hemisphere as dark as coal and the other as bright as ice. This stark contrast is due to material from another moon, Phoebe, coating one side of Iapetus, while the other side remains covered in bright ice. Can you picture such a celestial yin-yang in the night sky? Speaking of visual wonders, let's delve into the phenomenon of ringlets within Saturn's rings. These are narrow, tightly packed bands of particles that create a delicate lacework pattern within the broader ring structures. Scientists believe these intricate structures are the result of gravitational interactions with Saturn's moons and possibly embedded moonlets within the rings themselves. The ringlets are a beautiful example of how gravity can sculpt and maintain such delicate features over vast distances. Have you heard about the peculiar moon pan? It orbits within the Anchor Gap in Saturn's A-ring, and its shape is reminiscent of a flying saucer. This distinct form is believed to result from material from the rings accumulating on Pan's equator. The moon's gravitational influence keeps the gap open, demonstrating how even small bodies can have significant impacts on their surroundings. Another captivating fact involves Saturn's E-ring, the widest but one of the faintest of the rings. It's primarily composed of tiny ice particles ejected from the geysers of Enceladus, the same moon we spoke about earlier with its cryovolcanoes. These particles spread out to form a ring that's several times wider than Saturn itself, highlighting the dynamic relationship between the planet and its moon. Consider the shepherd moon Daphnis, which orbits within the Keeler Gap in Saturn's A ring. This moon's gravitational influence creates stunning wave-like ripples along the edges of the gap, a breathtaking display of celestial dynamics. It's like watching a stone dropped into a pond, where instead of water, the ripples move through particles of ice and rock. On another note, did you know about the possible subsurface ocean on Titan? Beneath its thick, icy crust, scientists believe there may be an ocean of liquid water mixed with ammonia. This subsurface ocean might harbor conditions suitable for life, making Titan one of the most intriguing targets in the search for extraterrestrial life in our solar system. There's also something quite fascinating about the interaction between Saturn's rings and its magnetic field. As the planet rotates, its magnetic field interacts with the particles in the rings, creating auroras at the planet's poles. These are similar to the northern and southern lights on Earth, but on a much grander scale, painting a picture of serene yet powerful cosmic activity. Imagine this: the moon Methone, with its remarkably smooth surface, devoid of any craters. This tiny moon, orbiting between Mimas and Enceladus, has a surface so smooth that it almost appears polished. Scientists are still puzzled by its unusual smoothness, speculating that its surface might be composed of some unknown material, or that the moon experiences constant resurfacing. And let's not forget about Saturn's moon, Tethys, which hosts Ithaca Chasma, a vast canyon system stretching almost 3/4 of the way around the moon's circumference. The formation of this canyon might be linked to the cooling and expanding of Tethys's interior, offering insights into the geological processes shaping moons in the distant realms of space. Finally, let's consider the delicate balance of Saturn's B ring. It's the brightest and most massive of the ring system, yet it remains remarkably thin, only a few tens of meters thick. This delicate balance is maintained through complex gravitational interactions with Saturn and its moons, illustrating the intricate harmony that governs celestial bodies. As you drift off, let your mind wander through these wonders of Saturn and its moons, imagining the celestial dance that unfolds beyond our sight, but perfectly choreographed by nature's laws. They're not as eternal as they may seem. While these ethereal bands of ice and rock are millions of years old, they are slowly but surely eroding. Known as ring rain, tiny particles from the rings are being pulled into Saturn's atmosphere, a process that will eventually lead to their disappearance. Can you imagine a time when future stargazers might look up at Saturn and see only a bare planet without its iconic adornments? It's a reminder of the impermanence of even the most majestic celestial features. And speaking of change, did you know that Saturn's rings are surprisingly dynamic? The rings are not just static bands of ice. They are in constant motion, with particles colliding, merging, and breaking apart. This constant activity is influenced by Saturn's gravitational pull, as well as the effects of its moons, creating a vibrant, ever-changing tapestry. If you could watch the rings over time, you'd see a cosmic ballet unfold, where particles dance to the rhythm of gravitational forces. Here's a fascinating fact about Saturn's moon, Rhea. It's the only moon in the solar system with its own rings. Although these rings are not visible in the same way as Saturn's, they are hinted at by changes in the moon's gravitational field and the distribution of particles around it. Imagine a moon with its own tiny halo, a miniature echo of the grand rings surrounding its parent planet. Another intriguing aspect of Saturn's rings is their incredible thinness. Despite stretching over 270,000 kilometers from one side to the other, The main rings are only about 10 meters thick. If Saturn were the size of a basketball, the rings would be thinner than a razor blade. This astonishing thinness is maintained by the delicate balance of gravitational forces, a testament to the precision with which the universe operates. Speaking of precision, let's turn our attention to one of Saturn's moons, Atlas. This moon is known for its unique UFO-like shape, which is the result of a prominent equatorial ridge. Scientists believe this ridge is formed by the accumulation of ring material similar to Pan. It's amazing how even the smallest moons can become cosmic architects, reshaping themselves with the material drawn from their surroundings. Consider the mysterious moon Enceladus, where icy geysers spew water vapor and ice particles into space. These geysers are not just a wonder to behold, they are also a source of material for Saturn's E-ring. Enceladus continues to amaze scientists as they study its potential to harbor life thanks to the presence of liquid water beneath its icy crust. Isn't it incredible to think that a moon so far from the warmth of the sun could hold secrets of life within its frozen exterior? Now, let your thoughts drift to the moon Dione. This moon, often overshadowed by its more famous siblings, offers its own surprises. Dione has a mostly icy surface with bright, wispy streaks believed to be ice cliffs formed by tectonic fractures. These cliffs reflect sunlight in a way that gives Dione a luminescent appearance, as if it were gently glowing in the cosmic darkness. Did you know that Saturn's moon Janus shares its orbit with another moon, Epimetheus? These two moons engage in a celestial dance as they swap positions every few years. This unique orbital arrangement, known as co-orbital motion, is a rare and fascinating example of gravitational choreography in the solar system. Imagine the intricate gravitational ballet performed by these two moons as they gracefully exchange places in orbit. Speaking of dances, have you ever heard of Saturn's ring arcs? These are partial rings that appear like bright streaks against the darkness of space. Unlike the full circles of the main rings, these arcs are thought to be held in place by the gravitational pull of nearby moons, creating an incomplete ring structure that is as mysterious as it is beautiful. Venturing further into the realm of the unknown, consider the intriguing shadows cast by Saturn's rings onto its cloud tops. These shadows change with the planet's seasons, creating a mesmerizing interplay of light and dark. As Saturn tilts on its axis, the shadows stretch and compress, offering a dynamic visual spectacle that transforms with time. One cannot forget about the moon Iapetus, with its equatorial ridge that reaches up to 20 kilometers high. This ridge encircles most of the moon and creates a remarkable appearance, almost like a walnut. Scientists speculate that this ridge might be the result of ancient tectonic activity or the remnants of a past ring system that collapsed onto the moon's surface. It's a striking feature that adds to the allure of Saturn's moons. Finally, let's contemplate the enigma of Titan's thick atmosphere, which is rich in nitrogen and methane. This atmosphere is so dense that it supports weather systems similar to Earth, with clouds, rain, and even stormy weather. Imagine standing under a methane rain shower or watching clouds drift across an alien sky. Titan's atmosphere offers a window into processes that could mirror those of the early Earth, providing a glimpse into the planet's primordial past. As your thoughts float lightly through the wonders of Saturn's rings and moons, consider the incredible tapestry of life and activity that unfolds in this distant corner of our solar system. Each moon, each ring particle, plays its own part in an ongoing story of cosmic evolution and transformation. So, let your imagination soar among these celestial companions, embracing the infinite mysteries they embody. Imagine, if you will, the moon Mimas, often likened to the Death Star from Star Wars due to its massive Herschel crater. This enormous impact site, over 130 kilometers wide, gives Mimas a distinctive appearance. It's fascinating to ponder that such a small moon, only about 400 kilometers in diameter, could harbor a crater so vast it nearly shattered the moon upon impact. Isn't it intriguing how cosmic events can create such iconic and recognizable features? Speaking of iconic features, consider the braided structure occasionally observed in Saturn's F ring. This ring is a dynamic and chaotic place where small moons, known as shepherd moons, weave through the ring material. These tiny moons help maintain the ring's shape and create the braided patterns by their gravitational influence. It's a mesmerizing dance of tiny celestial bodies weaving intricate patterns in the cosmic fabric. Have you ever wondered about the moon Hyperion? This moon is particularly fascinating due to its chaotic rotation. Hyperion tumbles erratically as it orbits Saturn, making it one of the few moons in the solar system with such unpredictable behavior. Its surface, riddled with deep craters, gives it a sponge-like appearance. The peculiar rotation of Hyperion results from its irregular shape and gravitational interactions with nearby moons, a testament to the dynamism of celestial mechanics. Turning our gaze back to the rings, let's explore the intriguing phenomenon of spokes. These mysterious radial features appear like ghostly shadows across Saturn's B ring, seemingly defying gravitational norms. Scientists believe they are composed of fine icy particles temporarily suspended above the ring plane. The formation of spokes is thought to be influenced by Saturn's magnetic field, revealing a hidden connection between the rings and the planet's magnetic environment. You might be surprised to learn about the moon Phoebe, which orbits Saturn in a retrograde direction, moving opposite to the planet's rotation. This peculiar orbit suggests that Phoebe may not have formed around Saturn, but was instead captured from the distant Kuiper belt. Its dark, carbon-rich surface stands in stark contrast to the icy moons closer to the planet, indicating a composition more akin to distant objects in the solar system. And here's something captivating. Saturn's rings are not uniform in composition. They consist of countless particles, ranging from tiny grains to large boulders, primarily made of water ice with traces of rocky material. The variation in size and composition creates a dazzling array of colors when viewed up close. This diversity within the rings adds an extra layer of complexity to their already fascinating structure. Shifting our focus to Titan once more, have you heard about its vast lakes and seas of liquid methane and ethane? The largest of these, Kraken Mare, is larger than the Caspian Sea on Earth. These hydrocarbon seas create a surreal landscape where waves can form under Titan's thick orange haze. Such liquid bodies offer a fascinating glimpse into the moon's climate and geological processes, challenging our understanding of both planetary and extraterrestrial environments. As we consider the influence of Saturn's gravity, we find that it's not only the rings that are affected, but also the moons themselves. The moon Tethys, for instance, bears a massive canyon system known as Ithaca Chasma. This chasm stretches over 1,000 kilometers, possibly formed in response to intense tidal forces that reshaped the moon's icy crust. It's remarkable how planetary forces can sculpt such vast and intricate features on distant worlds. Moreover, did you know that Saturn's rings are slowly disappearing? Over millions of years, the particles that make up the rings are gradually being pulled into Saturn by gravity. This phenomenon, called ring rain, sees ice particles falling from the rings into Saturn's atmosphere, where they disintegrate. This process implies that the rings are a relatively recent addition to the solar system and may not last forever. Have you ever considered the role of Saturn's shadow in the ring system? During Saturn's equinox, the planet's shadow falls across the rings, dramatically cooling them. This cooling can affect the ring's structure and appearance, sometimes causing temporary clumping of particles. The interplay of light and shadow on Saturn's rings during these times is a celestial event of breathtaking beauty and complexity. Reflecting on the moon Rhea once more, we find it has a wispy terrain, similar to Dione. These features could be remnants of ancient cryovolcanic or tectonic activity. The subtle beauty of these streaks invites us to imagine the geological history and processes that shaped this distant world. Lastly, let's delve into the captivating tale of Saturn's magnetosphere, the region dominated by the planet's magnetic field. This vast and dynamic area is filled with plasma originating from the rings and moons, particularly Enceladus. The interactions within the magnetosphere create auroras at Saturn's poles, similar to those on Earth. These shimmering lights are a reminder of the powerful unseen forces at play in the universe. As you drift into a peaceful slumber, let these wonders of Saturn's rings and moons fill your dreams with visions of cosmic elegance and celestial harmony. Each fact weaves into the grand tapestry of the universe, a gentle reminder of the beauty and mystery that await beyond our earthly skies. Imagine, if you will, the moon Enceladus, the small and icy body that harbors a remarkable secret beneath its frozen surface. This moon is one of the few places in the solar system where liquid water exists beneath the surface, hidden beneath an icy crust. Scientists have discovered geysers erupting from Enceladus's south pole, spewing water vapor and ice particles into space. These geysers create a plume that feeds material into Saturn's E-ring, making Enceladus an active participant in the ring system's dynamics. The presence of water raises intriguing possibilities about the potential for life beneath its icy shell. Speaking of icy wonders, let's consider Saturn's moon Mimas, often likened to the Death Star from Star Wars due to its massive crater Herschel. This crater is a whopping 130 kilometers wide, nearly a third of the moon's diameter, and its impact must have been a colossal event. The crater's massive central peak and steep walls tell a story of ancient cosmic collisions that have left a lasting mark on Mimas's appearance. And here's an intriguing thought. Some of Saturn's rings may actually be remnants of ancient moons. It's believed that some of the rings could have formed from moons that were shattered by collisions or torn apart by Saturn's immense gravitational forces. This process of destruction and rebirth highlights the dynamic and ever-changing nature of Saturn's ring system. Have you ever pondered the role of small moons acting as sculptors of the rings? These moons, often referred to as shepherd moons, orbit near the rings and carve out gaps within them. Their gravitational influence can create spectacular structures like the Cassini division, a prominent gap separating the A and B rings. The delicate balance between these moons and the ring particles they shepherd creates a mesmerizing dance that shapes the ring's intricate patterns. Now, shifting our gaze to the colors of Saturn's rings, did you know that they can change over time? The hues of the rings can appear different depending on the angle of sunlight and the amount of material in the rings. This variability can be attributed to seasonal changes on Saturn, which affect the rings just as they do the planet's atmosphere, adding a temporal dimension to their already complex structure. The moon Iapetus, another of Saturn's fascinating satellites, presents a striking two-tone appearance, One hemisphere is as bright as snow, while the other is as dark as coal. This stark contrast remains a mystery, but scientists suspect that the dark material may be debris from other moons or micrometeoroid impacts, coating one side of Iapetus as it travels through space. Consider now the peculiar moon Pan, shaped somewhat like a ravioli. Orbiting within the anchor gap of Saturn's A-ring, Pan's equatorial ridge gives it this unique appearance. The ridge is thought to be the result of ring material accumulating on the moon's surface, sculpting its unusual shape over time. Among the many wonders of Saturn, have you heard about the moon Dione? It has bright, wispy streaks across its surface that are quite similar to those on Rhea. These features were initially thought to be icy cliffs, but are now believed to be tectonic fractures, revealing the moon's dynamic past. Now, turning our attention to Saturn's magnetosphere once more, there is a fascinating interplay between it and the moons that orbit within it. The interaction between the magnetosphere and the particles ejected from Enceladus creates a torus of plasma, a donut-shaped cloud that encircles Saturn. This plasma torus influences the dynamics of the magnetosphere and contributes to the auroras seen at the planet's poles. Have you ever imagined that Saturn's rings could actually sing? In a manner of speaking, they do. The particles in the rings collide and interact in ways that can generate radio emissions, detectable by instruments on spacecraft like Cassini. These emissions translate into eerie, beautiful sounds when converted into audio frequencies. The moon Titan, with its thick atmosphere and surface lakes, is also home to towering dunes of icy and organic material. These dunes, some reaching hundreds of kilometers in length, are shaped by the strong but gentle winds of Titan's dense atmosphere. The dunes provide a glimpse into the moon's climatic processes and the fascinating interactions between wind and surface on another world. Furthermore, let's consider the moon Tethys once again. This icy moon is home to a gigantic impact crater named Odysseus, which spans more than 400 kilometers across. The scale of Odysseus is such that the impact must have caused massive shocks throughout Tethys, yet the moon remains intact, a testament to its resilience in the face of cosmic collisions. Imagine too the moon Rhea, which may have its own system of rings. Though these rings have not been directly observed, evidence suggests that Rhea might possess a tenuous ring system formed by dust and debris orbiting the moon. This possibility extends the complexity of Saturn's ring systems beyond the main rings that encircle the planet itself. And finally, ponder the moon Janus, which shares its orbit with the moon Epimetheus. These two moons dance around Saturn in a unique orbital configuration, swapping positions every few years. This intricate orbital exchange, known as co-orbital motion, is a rare and fascinating example of celestial choreography. As you let these wonders settle into your thoughts, imagine drifting into a celestial dream, where the moons and rings of Saturn swirl gently around you, whispering tales of cosmic history and the mysteries yet to be unraveled. Picture Saturn's rings as a cosmic masterpiece, with each particle playing its part in a vast celestial canvas. Did you know that the particles within these rings range in size from tiny grains of dust to massive chunks the size of a house? It's extraordinary to think that this delicate balance of different sized particles creates such a stunning visual spectacle from afar. And speaking of these particles, they are mostly composed of water ice. The purity of this ice is what gives the rings their brilliant, reflective appearance, allowing them to shine brightly against the backdrop of space. Imagine for a moment the immense speed of these particles, some of which travel at tens of thousands of kilometers per hour. Despite their frenetic pace, The particles maintain their elegant formations, an intricate dance governed by the gravitational forces of Saturn and its moons. Isn't it fascinating how order emerges from what seems like chaos? Now, let me share something intriguing about Saturn's moon Hyperion. This moon has a distinctly sponge-like appearance, with the surface dotted by deep craters and a chaotic rotation that ensures no 2 days are the same. Hyperion's irregular shape and low density suggest it might be a remnant of a larger body that was shattered long ago, leaving this peculiar moon as a testament to its turbulent past. Considering the ring system's age, scientists estimate that Saturn's rings are relatively young in cosmic terms, possibly forming just 100 million years ago. While that might sound ancient to us, it's only a fraction of Saturn's 4.5 billion-year-old history. The youth of the rings raises questions about their origin, whether they are the remnants of a destroyed moon or the product of some other cataclysmic event. Another surprising feature is Saturn's E-ring, which is largely composed of ice particles from Enceladus. This moon actively spews out geysers of water vapor and ice from its subsurface ocean, feeding the E-ring and adding an element of mystery to the moon's internal dynamics. Can you imagine the spectacle of these icy plumes erupting from Enceladus, contributing to the ring's ethereal beauty? Speaking of plumes, the geysers on Enceladus are not just a visual wonder. They contain organic molecules hinting at the possibility of life beneath the moon's icy surface. The presence of these molecules in the plumes suggests that Enceladus might have the right conditions for microbial life, with a subsurface ocean that could potentially harbor living organisms. Turning our gaze to Titan, it's worth noting that this moon has lakes of liquid methane and ethane, a stark contrast to Earth's water-based bodies. These lakes and seas are part of a dynamic cycle, much like the water cycle here on Earth, with methane rain falling from Titan's thick atmosphere, collecting in lakes and possibly forming rivers that carve into the icy landscape. Additionally, Titan's atmosphere is so dense that it creates a prolonged twilight, with sunlight scattering through the thick haze long after the sun has set. This extended twilight bathes the Titanian landscape in a soft, diffused glow, creating an environment that is both alien and strangely familiar. Let me also tell you about the moon Phoebe, an irregularly shaped satellite that orbits Saturn on a path opposite to that of most other moons. This retrograde orbit suggests Phoebe might have originated from the distant reaches of the solar system, possibly captured by Saturn's gravity. Its dark, carbon-rich surface is reminiscent of ancient primordial bodies from the outer solar system, providing valuable clues about the early days of our cosmic neighborhood. Considering Saturn's gravitational influence, it's fascinating how it affects not just its rings, but also the orbits and shapes of its moons. The moon Epimetheus, for instance, has a potato-like shape due to the constant tugging of Saturn's gravitational pull, reminding us of the continuous dance of forces at play within this planetary system. And here's a whimsical thought. The rings of Saturn are not entirely flat. The gravitational interactions with moons like Prometheus and Pandora cause vertical waves and kinks within the rings, creating a three-dimensional texture that adds depth to the already complex system. These subtle undulations ripple through the rings, adding another layer of beauty to their celestial choreography. Let's not forget about Saturn's magnetic field, which is unique in its near-perfect alignment with the planet's rotation axis. This alignment is unlike that of any other planet in our solar system and challenges existing models of planetary magnetism, opening new avenues of inquiry into the mysteries of how such fields are generated and maintained over time. Finally, consider the Saturnian weather. The planet's atmosphere hosts massive storms, some of which are so large that their tumultuous clouds can be seen from Earth. These storms, fueled by the planet's rapid rotation and internal heat, create mesmerizing patterns in the bands of clouds encircling the planet, each one a snapshot of dynamic atmospheric conditions far beyond our own world. As you ponder these remarkable aspects of Saturn and its entourage, imagine the vastness of space, where each moon and ring particle plays its role in a grand cosmic tale. May these celestial wonders fill your mind with dreams of distant worlds, where the mysteries of the universe await exploration. Saturn's system is truly a treasure trove of wonders, each moon and ring contributing to the planet's mystique. Did you know that Saturn's moon Rhea might have its own set of rings? Although not as visually striking as the planets, there's evidence suggesting faint rings encircle Rhea, possibly composed of icy particles unseen by the naked eye. This would make Rhea the only moon in our solar system known to host such a feature. Another fascinating aspect is the moon Iapetus, with its stark two-toned surface. One hemisphere is as dark as coal, while the other shines bright like freshly fallen snow. This striking contrast is believed to be the result of material from a distant moon, Phoebe, bombarding Iapetus and coating one side, while the other side remains clear. Speaking of Phoebe, its retrograde orbit isn't its only claim to fame. This moon has a notably different composition compared to Saturn's other moons, suggesting it might be a captured centaur, a class of icy bodies that orbit between Jupiter and Neptune. If true, Phoebe serves as a window into the early solar system, offering clues about the primordial materials that formed planets. Next, let's explore Dione, a moon with fascinating geological features. Its surface is covered by bright ice cliffs, which stand out against the darker terrain. These cliffs are thought to be the result of tectonic fractures, demonstrating that even small moons can have active geologic histories. The moon Tethys, on the other hand, boasts a massive canyon system known as Ithaca Chasma. Stretching roughly 3/4 of the moon's circumference, this chasm likely formed when the moon's subsurface ocean froze and expanded, cracking the icy crust above. It's a reminder of the dynamic processes shaping celestial bodies. Saturn's rings themselves hold secrets, such as the curious spokes that sometimes appear. These radial features are possibly caused by the planet's magnetic field interacting with tiny charged particles in the rings, creating temporary patterns that resemble the spokes of a wheel. These formations are fleeting and add a touch of mystery to the constantly shifting ring system. Turning our attention back to Enceladus, scientists have discovered that its ocean beneath the icy crust is global, extending completely around the moon. This ocean is kept warm by tidal forces from Saturn's gravity, which generate heat through friction. The discovery raises the intriguing possibility of life in the hidden depths, sustained by both chemical and thermal energy. In another intriguing twist, the moon Mimas, often compared to the Death Star from Star Wars due to its large crater, may also have a subsurface ocean. While it lacks the icy geysers of Enceladus, measurements of its wobble suggest that something beneath the surface is shifting, possibly indicating liquid water. The rings of Saturn, while breathtaking, are not eternal. Gradually they are being pulled into the planet by gravity in a process known as ring rain. This phenomenon, caused by the planet's magnetic field, could see the rings disappear in 50 to 100 million years, making their current splendor a transient celestial feature. Have you ever wondered how the moons maintain their orbits so precisely? The answer lies in a fascinating phenomenon called orbital resonance. Take the moons Titan and Hyperion, for example. Their orbits are in such harmony that for every 4 orbits Titan completes, Hyperion completes exactly 3. This gravitational relationship helps stabilize their paths around Saturn. Even the smallest of Saturn's moons have surprises in store. Atlas, a tiny moon, has a unique shape resembling a flying saucer due to the accumulation of ring material along its equator. This shape is a direct result of material from the rings settling on the moon's surface, highlighting the intimate connection between the rings and their moons. The moon Janus, along with its sibling Epimetheus, performs a unique orbital dance. These moons are co-orbital, sharing nearly the same path around Saturn. Every few years they swap positions in a gravity-assisted maneuver that sees them trade orbits without ever colliding, a testament to the delicate balance maintained in the Saturnian system. Did you know that Saturn's rings can be a source of fascinating sounds? As particles collide and interact within the rings, they create radio emissions that can be converted into eerie, otherworldly sounds. Listening to these cosmic symphonies offers a new way to appreciate the ring's dynamic nature. Finally, consider the role of Saturn's gravitational well. This immense force not only shapes the rings and orbits of its moons, but it also captures countless meteoroids, preventing them from impacting the inner solar system. In this way, Saturn acts as a cosmic gatekeeper, safeguarding planets closer to the Sun from potential harm. With all these intriguing details, Saturn's rings and moons paint a portrait of a dynamic, ever-evolving system. The mysteries they hold invite us to ponder the complexities of the universe and our place within it. As you drift into slumber, perhaps you'll dream of exploring these distant, icy worlds where the wonders of the cosmos continue to unfold. Let me share something interesting with you about the moon Titan, Saturn's largest and perhaps most enigmatic satellite. Did you know that Titan is the only moon in our solar system with a dense atmosphere? This thick layer of gases, primarily nitrogen with a hint of methane, creates an environment somewhat reminiscent of early Earth. The atmosphere is so rich and heavy that it completely obscures the surface from view and visible light. This means that when we gaze at Titan, we're not just seeing another icy moon, but a world shrouded in mystery, with its secrets hidden beneath an orange haze. Speaking of Titan, it has another fascinating feature. Its surface is dotted with lakes and seas, not of water, but of liquid methane and ethane. These hydrocarbon bodies are replenished by rains from methane clouds above, forming a hydrological cycle similar to Earth's, yet with substances that would be strange and alien to us. Imagine standing on Titan's surface, where the gentle drizzle of methane rain creates ripples on the lakes, a truly otherworldly experience. Here's a curious tidbit about Saturn's rings. They are made up of countless small particles, ranging from tiny icy grains to house-sized chunks. These particles are primarily composed of water ice, but did you know that some of them may carry a thin coating of cosmic dust? This dust, accumulating over millions of years, adds a subtle dusty hue to certain parts of the rings and tells a silent story of their ancient origins. And while we're on the topic of Saturn's moons, let me tell you about a peculiar phenomenon involving the moon Enceladus. This moon is famous for its geysers, which spew water vapor and ice particles into space. Intriguingly, these plumes contain complex organic molecules, including those that form the building blocks of life. This discovery raises exciting questions about the potential for life beneath Enceladus's icy surface, hidden in the depths of its global ocean. Did you know that the tiny moon pan also showcases a unique shape? Resembling a ravioli or a walnut, Pan's unusual form is thought to be the result of the accretion of ring material around its equator, much like Atlas. This process highlights the dynamic interactions between Saturn's moons and its rings, where even the smallest satellites can bear the marks of the cosmic environment they inhabit. Let me take you back to Saturn's rings for a moment. Have you ever wondered how thin they are? In cosmic terms, they're incredibly delicate. Although they extend over 270,000 kilometers in diameter, the rings are only a few tens of meters thick on average. Imagine a vast, shimmering disk that, despite its colossal breadth, is as thin as a sheet of paper relative to its size. This breathtaking delicacy makes the rings both beautiful and ephemeral, like a cosmic veil draped around the planet. Another fascinating aspect of Saturn's moons is the peculiar behavior of the moon Hyperion. Unlike any other moon, Hyperion rotates chaotically, its irregular shape and gravitational interactions causing it to tumble unpredictably. This erratic spinning gives Hyperion a unique characteristic, making each encounter with this moon a new experience, as its orientation can never be predicted with certainty. And here's something rather unexpected about the moon rear. Recent studies suggest it might have a thin atmosphere made of oxygen and carbon dioxide. Although it is too tenuous to support life as we know it, this subtle atmosphere is a surprising feature for a moon that was once thought to be little more than an icy rock. It hints at the complex interactions between Rhea's surface and the space environment, a reminder of the surprises that await us in the cosmos. Let me tell you about the intriguing effect of Saturn's magnetic field. It extends far beyond the planet itself, enveloping the rings and many of its moons. This magnetic field traps charged particles, creating intense radiation belts. These belts can influence the surfaces of moons like Mimas, altering their chemical compositions and even affecting the potential habitability of subsurface oceans. Speaking of intriguing details, the moon Tethys hosts a massive crater called Odysseus, which spans nearly half its diameter. This colossal impact site is a testament to the violent past that shaped the solar system, where celestial collisions were not just common but formative events, sculpting the surfaces of planets and moons alike. Did you know that Prometheus and Pandora, two of Saturn's smaller moons, are known as shepherd moons? They help keep Saturn's thin F ring in check, their gravitational forces corralling the ring particles and maintaining its distinct shape. This dynamic system is another example of the intricate and delicate dance between Saturn's rings and its moons, where even the tiniest celestial bodies play a vital role in the structure of the rings. Lastly, consider the idea of Saturn as a miniature solar system. With over 80 known moons, each with its own unique characteristics and its magnificent rings, Saturn offers a glimpse into the diversity and complexity of celestial bodies. These moons and rings, with their myriad mysteries and interactions, invite us to dream about the countless stories hidden among them, stories that continue to unfold as our understanding of the universe deepens. With these thoughts in mind, as you settle into sleep, imagine the gentle pull of Saturn's gravity, the rings shimmering softly and the moons quietly orbiting, each one a world unto itself with tales yet to be told. Have you ever thought about the mysterious moon Iapetus and its stark appearance? This moon presents a striking contrast, with one hemisphere dark as coal and the other bright as snow. Scientists believe this dual-toned appearance may be due to material from other moons or the rings coating one side, while icy material resurfaces the other. It's like a cosmic yin and yang, a constant reminder of the diverse processes at play in the solar system. Speaking of contrasts, did you know that the moon Dione holds clues to a potentially active history? While it appears quieter today, evidence of tectonic fractures on its surface suggests that Dione might have once been geologically active. Imagine the forces that could crack an icy moon, creating deep canyons that speak of a dynamic past. Another engaging feature of Saturn's moons is the subsurface ocean on Titan, which scientists have discovered beneath its icy crust. This ocean is composed of water mixed with ammonia, which lowers the freezing point and keeps the ocean in a liquid state. It's fascinating to think that beneath Titan's thick atmosphere and icy surface lies a vast hidden sea that could be more than 100 kilometers deep. Have you ever wondered how long the rings of Saturn will last? It turns out they might be relatively short-lived on a cosmic timescale. Recent studies suggest that the rings are slowly losing mass as material rains down onto Saturn. This process, known as ring rain, could mean that Saturn's iconic rings may vanish in as little as another 100 million years. It's humbling to consider that a feature so iconic to us now is but a temporary adornment in the planet's long history. Here's something rather poetic. The moon Mimas, often likened to the Death Star due to its enormous crater, is not just a static ice ball. Its slight wobble as it orbits suggests the possible presence of a subsurface ocean, which could mean Mars is more dynamic than it appears. This hidden ocean, if present, adds a layer of mystery to the moon's icy visage. In the vast array of Saturn's moons, one of the more curious is Phoebe. This irregularly shaped moon is believed to be a captured object from the distant Kuiper belt, a region beyond Neptune filled with icy bodies. Phoebe's dark, carbon-rich surface stands in stark contrast to many of Saturn's other moons, hinting at a different origin story and a journey from the outer reaches of the solar system. Speaking of journeys, did you know that Saturn's rings exhibit complex waves and patterns caused by gravitational interactions with its moons? These spiral waves propagate through the rings, creating a symphony of movements. Each wave tells a story of interaction, of moons tugging at the rings and setting off ripples that traverse the expanse. While we're on the topic of interactions, consider the moon Rhea, which may have its own system of rings. Although not as grand as Saturn's, Rhea's potential rings are a fascinating possibility, suggesting that even moons can have mini ring systems. These ghostly rings would be made of tiny particles, challenging to observe but adding another layer of intrigue to Saturn's family of moons. Enceladus, with its famous plumes, holds yet another secret. These geysers are not just water vapor, but also contain silica particles. These tiny grains suggest that there may be hydrothermal activity occurring on the ocean floor beneath Enceladus's ice shell. Such activity could create environments similar to those where life thrives on Earth, inviting us to consider the possibility of life in places far more exotic. And here's a thought-provoking detail about the moon Janus. It shares its orbit with another moon, Epimetheus. These two moons perform a celestial dance, swapping places every 4 years in a marvelous display of orbital mechanics. Their gravitational interaction keeps them from colliding, demonstrating the delicate choreography inherent in Saturn's intricate moon system. Have you ever imagined the scale of Saturn's rings? While they seem vast, they contain less mass than you might expect. If gathered together, the material of the rings would form a body only 100 kilometers across, smaller than many of Saturn's moons. It's amazing to think that such a thin veil of particles can create the brilliant spectacle we observe. Another captivating aspect is the moon atlas, which, like Pan, has a distinctive ridge around its equator. This ridge gives Atlas a flying saucer-like appearance, which likely formed from accumulated ring material. It's a vivid example of how Saturn's rings influence the shapes and characteristics of its moons, sculpting them in the planet's cosmic workshop. Here's a final, intriguing tidbit. Saturn's rings may have formed more recently than previously thought. Rather than being ancient relics from the solar system's formation, they might be the remnants of a destroyed moon or comet that wandered too close. This possibility paints a picture of a dynamically evolving system, where the past and future of celestial bodies are in constant flux. With these enchanting tales from Saturn's realm, allow your imagination to drift among the rings and moons, where each fact is a gentle whisper from the cosmos. As you gaze into the night sky, remember that our universe is filled with wonders yet to be discovered and stories yet to be told, lulling you into a restful slumber under the watchful gaze of the stars. Allow me to share something truly fascinating. The moon Hyperion, with its sponge-like appearance, is not only irregular in shape, but also chaotic in its rotation. Imagine a moon that doesn't spin predictably like a top, but instead tumbles unpredictably through space, its orientation never repeating in a fixed cycle. This erratic spin is due to Hyperion's highly eccentric orbit and gravitational interactions with Titan, another of Saturn's moons. It's remarkable to think about how dynamic and unpredictable the cosmos can be. Speaking of unpredictability, did you know that Saturn's rings might be less solid than they appear? Despite their shimmering beauty, they are composed mostly of ice particles, with a bit of dust and other material. These particles range in size from tiny grains to chunks the size of a house, all moving at different speeds and sometimes even colliding with one another. It's as if the rings are a cosmic ballet, each particle playing its part in a dance that has been ongoing for millions of years. And here's an intriguing detail about the moon Iapetus. It has a stark dichotomy between its two hemispheres. One side is as bright as snow, while the other is as dark as coal. This dramatic contrast is due to a process known as thermal segregation, where ice sublimates from the warmer, brighter side and redeposits on the cooler, darker side. Can you imagine a moon with such striking visual differences, almost like a cosmic yin and yang? Let me share a curious fact about Titan's lakes. Unlike Earth's lakes, which are filled with water, Titan's lakes are composed of liquid methane and ethane. These hydrocarbons exist in liquid form due to Titan's frigid temperatures. It's a world where a hydrological cycle occurs with these exotic liquids, creating rain, rivers, and lakes, in a landscape reminiscent of Earth, yet utterly alien. You might find it surprising that Saturn's rings exhibit seasonal changes. Just as Earth goes through seasons, so does Saturn, albeit over much longer periods. Over the course of Saturn's nearly 30-year orbit around the Sun, the angle of sunlight on the rings changes, affecting their brightness and visibility. It's a slow, majestic transformation, reminding us of the endless cycles that govern our solar system. A captivating fact about Saturn's moon Rhea is its potential to harbor a thin atmosphere composed mostly of oxygen and carbon dioxide. Although extremely tenuous compared to Earth's atmosphere, this exosphere is created by the interaction of Saturn's magnetosphere with Rhea's icy surface. It's amazing to consider that even a small moon can have an atmosphere, however thin, hinting at the complex interactions between celestial bodies. Have you ever wondered about the mysteries hidden beneath the surface of Saturn's moons? Consider the moon Tethys, which, despite its cold, icy exterior, may conceal a subsurface ocean. This possibility arises from the moon's orbital resonance with other moons, which generates internal heat. Such oceans are compelling because they could offer environments where life might exist, sheltered from the harsh conditions of space. In the grand tapestry of Saturn's rings, one of the most intriguing features is the spokes that occasionally appear. These mysterious, transient features are thought to be caused by tiny charged particles levitated above the ring's surface by Saturn's magnetic field. Imagine spokes of dust and ice, appearing and disappearing as Saturn's magnetic field interacts with the ring particles, a phenomenon that still puzzles scientists today. And consider the moon Pandora, which along with its partner moon Prometheus, acts as a shepherd to Saturn's F-ring. These moons help maintain the ring's structure by gravitationally corralling the particles, preventing them from spreading out into space. It's a delicate balance where the moons, like cosmic shepherds, guide the ring particles in their eternal orbit around Saturn. Here's a delightful thought. Saturn's rings, though vast, are astonishingly thin. If you could scale them down to the size of a football field, they'd be thinner than a sheet of paper. This delicate structure is a testament to the intricate forces at play in the cosmos, where gravity and motion shape the universe in surprising ways. Speaking of the surprising, let's turn to the moon Dione, which, like Enceladus, might have a subsurface ocean. This revelation, based on gravitational data, opens up the possibility that more of Saturn's moons could hold hidden oceans, increasing the chances of finding life beyond Earth. It's a thought that invites wonder, imagining the hidden worlds beneath icy crusts, waiting to be discovered. The moon Titan, with its thick atmosphere and methane lakes, also exhibits something extraordinary: a possible cryovolcano known as Doom Mons. This feature could be actively erupting cryogenic magma composed of water and ammonia, reshaping Titan's surface. Such volcanic activity is a reminder of the dynamic processes that can occur on icy worlds, where even the coldest environments can harbor warmth and change. Let me share one more intriguing aspect. The moon Pan, residing within the anchor gap of Saturn's A-ring, has a shape reminiscent of a ravioli or walnut. This unusual shape is likely due to the accumulation of ring material forming a prominent equatorial ridge. It's another example of how Saturn's rings sculpt its moons in unique and unexpected ways. With these mesmerizing tales from Saturn's realm, relax into the thought that the universe is vast and filled with wonders beyond our current understanding. Each fact, like a gentle cosmic lullaby, invites you to dream of distant worlds and the mysteries they hold. As you drift into restful slumber, let the stories of Saturn's rings and moons wrap around you like a soft blanket, reminding you of the beauty and wonder that exists in the cosmos.